and welcome to this short demo of Eclipse FreeBIRD tools. We want to show the basic flow of the application here. There's a main flow, so let's just jump into it. So you can run this yourself, you don't need to install anything. You can go to the GitHub page for Eclipse FreeBIRD tools, EFBT. You choose the master branch and we do code, start code space. And this will start up the application. It's running in a virtual machine somewhere in the cloud, so it's very secure and maintained by Microsoft, so it's very stable. This takes maybe a minute to start up, so I'll pause the video. Okay, the application is started up, so we see here the FreeBIRD application. We want to look at the workflow. We'll see that we're going to choose a content repository of bird content, and this is a GitHub repository that you can manage yourself. It takes a copy of the artifacts that were published by Bird, and it does any changes or improvements that we want to do directly on the repository that you choose. We can have a look at that repository. We see we did some minor changes already here, all under source control, so you can see who changed what, why, and when. Also, we create a link to a test suite here, more on that later. So what we do here is we click on Retrieve Artifacts, and this is going to get those artifacts, the ones published by Bird and stored on this GitHub repository. This is our starting point. And then with those retrieved, we're going to click on Set Up Database, and that's going to create us a database with the tables of Bird. We use a database system called SQLite, but we can use other things like Oracle and Microsoft SQL Server also. So we'll click Set Up Database. This takes about 20 seconds, I think. Then we'll see here to help us create bird transformations, we have what's called the join configuration, where we give some sample information about how to join information in Bird together. More of a technical concept. We'll just show the tables here. We see we have these product categories. So we say, for example, we have something called other loans for related to type instrument 114, which is a bird concept. And we'll say other loans. Well, we need to use the instrument table, the instrument roll table, party table, etc. So we'll come back to that later. Now we want to run these 4 steps in our Bird workflow. One is to create SMCube's content, so create a set of metadata according to Bird but stored in a database for us. Then transformation rules and SMCubes, which are typically defined as something called cube links, cube structure item links. Then translate those into Python and then execute the Python against the data in the test suite and the database and show the results. So to do this, we do auto mode. So we see run task from task 1 to task 4. And we start. And this will take about 2 minutes, so we'll pause the video. Okay, that is completed, so we can review the results of these steps. So if we review the creation of SMCube's transformation rules, we'll see here we can look at the cube links, which are a kind of summary of joins that need to be done, for example. Let's look at those for FO5. And we do this per product, so we'll do this for other loans. So we generate cube links per product. And then we visualize this. We note that this was created by this matching between what we call output layers in Bird. So the output format, we want in an FO5 output cube. How do we map these to what's relevant in the input for a particular product? It might be different for other loans, might be different for debt securities, for example. And so we have automated gap analysis for this, and we nicely visualize the result. We might also find in some cases that it didn't find the correct location for something. Often this could be if you're making a new report that something is missing in the data model, so this is a way to find the gaps in the data model automatically instead of manually. So here we see our cube links. We can edit those also if we wanted to, with the basically edit feature here of editing cube links and editing cube structure item links, and we can add new ones if we wish. So after those BIRD SM cubes transformations are created, SM cubes being the meta model of BIRD, we create the Python transformation rules. These are a bit technical, but we can look at these and edit them. These are rules that will run in Python. And then we can look at what we did is we loaded in this test suite, and we can review the results of this automated run. Here we see there were 4 tests, and each one we loaded in a scenario. For example, this was a loan and a guarantee. We loaded this into the BIRD database. Here we had an expected result in our test suite of 11, but we found the result was 0, so we failed that test. And what this means is that when we see a problem with transformation rules, we can fix the problem and we test and regression test immediately. We don't wait 2 months for a release and then 3 months for someone to build an implementation of the release. No, we make a change, we test it straight away. This gives a better, tighter quality cycle. So let us go back to our main dashboard. So we saw here that the Python rules were run, but we might want to run them sort of manually ourselves. So we can go back to the home of the FreeBIRD application, look at populated templates, look at FinRep F0501. And then these are the different report cells. We don't show in a nice neat grid, but these are the different report cells of F05, FinRep F05. I happen to know off by heart that the data point 152589 is row 60, column 5. So I'm going to run this. The test data is still in the system because we ran the tests. We get a number for that cell of 83 million or so. We can go to the lineage viewer and we can see the detailed lineage of this calculation. Here we do full lineage. This is not the easiest thing to interpret, but we also export the detail of that as a JSON, which is also not the easiest to interpret. But what we're doing with these JSON files is we're loading it into a 3D visualization, 3D visualizer, which is a work in progress, but it's come quite far. So we can look at that 3D visualization. It's auto-created in something called Unity. So here we have the F05 report, we have the column 10, we'll see shortly there's a row 60 here. This might look a bit strange at first, but this is because we're showing attribute lineage or metadata lineage between concepts and BIRD, and also data lineage, because we populated these tables with our test data and then ran the calculations and shown the data lineage of how numbers go from data model to report. So if we look at this first at the high level, we'll see column 10 came from here in what we call the other loans slice, and carrying amount there came from it's a slightly older version of it, but carrying amount in the BIRD instrument role table. So what is this slice? This goes back to the joins I mentioned earlier. We create basically for each report a join for each relevant product. So for FinRep F05 I create a join for other loans, which are like term loans in the parlance of BIRD, and also credit card debt, and also advances and financial leases. And we also create join for non-negotiable bonds, because these should be included within FinRep according to the rules. We show only 2 joins here, one for other loans and one for non-negotiable securities. And we'll see that other loans linked these tables, like instrument table. But for non-negotiable securities, we link different tables that were related to securities. So if we go again, we can look at the metadata lineage here. We look at the red lines, which are related to this join for other loans. And the red lines show us neatly the metadata lineage of all the different attributes, right from report cell to the source input tables of BIRD. If we look at it in this way, we see the data lineage. So for our small test data sample, we can see how all the numbers transfer through the path from source data into finally the report cell. And we note here this is quite easy to visualize on a join by join basis, or we call it slice by slice basis. BIRD gives some freedom in implementation of how we choose to make joins. We can consider the cube links as a kind of specification of the joins that we need. One possibility is to make joins for every single report cell. In our view, creating thousands of joins to run those in a large data set is pretty expensive in terms of implementation, and also to maintain them, I would say, is very challenging also. So we go for an approach where we have one join per product. When we look at something like FO5 is a bit similar to having one join per row, or one intermediate cube per row. Not identical, because the product is not exactly the same as a row, but a very similar approach. So we hope you find that interesting. We try in this product to make everything as visual as possible, so it's easy to point to things, to discuss, etc. And also we've shown here how to create executable transformations, but a large part of the tool is also to create new reports. So if you wanted to do liquidity or market risk or something, you could have a shot at doing this all using the standards that are used to define BIRD content by the BIRD project. Also, it's possible to do this in a collaborative fashion, all managed by GitHub with code review and approval process also. So it's a very quick, rather lightning demo of Eclipse FreeBIRD tools, but I hope you find it interesting. Thank you for watching.